American V8 engines have long been celebrated for their power, character, and unmistakable rumble, icons of performance and freedom on the open road. But not every V8 has lived up to the legend. Over the decades, some engines rolled off production lines burdened with poor designs, questionable engineering choices, and crippling reliability issues. These mechanical missteps not only frustrated owners, but also left lasting scars on the reputations of some of America's biggest automakers. Number 20. 1978 Oldsmobile 5.7-liter diesel V8 LF9. In 1978, General Motors attempted to jump on the diesel bandwagon with the Oldsmobile 5.7-liter LF9 V8, hoping to capitalize on the fuel crises of the 1970s. Diesel engines were known for better fuel economy, and GM saw an opportunity to offer diesel-powered passenger cars to Americans eager to save at the pump. Unfortunately, instead of developing an all-new, heavy-duty diesel from the ground up, GM took a dangerous shortcut. They converted an existing gasoline Oldsmobile 350 small block into a diesel engine. That decision would go down as one of the most infamous missteps in American automotive history. The gasoline-based block simply wasn't strong enough for the extreme compression ratios required in diesel operation. A proper diesel engine is designed with reinforced internals, thicker cylinder walls, and robust head bolts to handle the intense pressures of combustion. The LF9 lacked these upgrades, and its head bolt pattern, inherited from the gas version, was completely inadequate. This design flaw led to blown head gaskets at alarming rates, sometimes within just a few thousand miles. Once the gasket failed, coolant and oil would mix, leading to catastrophic engine damage. To make matters worse, GM omitted a fuel-water separator in the fuel system, a critical component for any diesel engine. Diesel fuel in the United States at the time often contained water contamination, and without a separator, water would quickly corrode the injection pump and injectors. This resulted in poor running, hard starts, and frequent injector failures. The LF9's performance was another sore spot. With only around 120 horsepower and sluggish acceleration, the engine struggled to motivate the large, heavy Oldsmobiles, Cadillacs, and Buicks it was installed in. Drivers expecting diesel torque were often disappointed by its lackluster pulling power, especially when compared to European diesels of the era. Reliability was so poor that entire fleets of these cars were sidelined within a few years. Warranty claims skyrocketed, costing GM millions. The LF9 disaster even spawned class action lawsuits from angry owners who accused GM of knowingly selling defective engines. In some states, the fiasco helped push forward stronger lemon laws to protect consumers from such engineering blunders. Perhaps the most damaging legacy of the Oldsmobile diesel was its effect on public perception. Before the LF9, American buyers were open to the idea of diesel passenger cars. Afterward, the very word diesel became synonymous with unreliability and costly repairs in the U.S. market. This stigma lingered for decades, hampering diesel car sales well into the 21st century. By 1985, GM quietly withdrew the LF9 from production, but by then the damage was done. The Oldsmobile 5.7-liter diesel had cemented its reputation as one of the worst engines ever built, not just in America, but globally. Today, it stands as a textbook example of what happens when cost-cutting and rushed engineering take precedence over proper design and durability. For many enthusiasts and mechanics, the LF9 is not just the most hated American V8 of its time, it is the cautionary tale to end all cautionary tales. Number 19. 1982 Cadillac 4.1-liter HT4100 V8. When Cadillac rolled out the 4.1-liter HT4100 V8 in 1982, it was supposed to represent the brand's technological pivot into the modern, fuel-conscious era. The HT stood for high technology, and the engine featured a lightweight aluminum block with cast-iron cylinder liners, a departure from Cadillac's traditional heavy, all-iron designs. On paper, the new engine offered improved fuel economy and reduced weight, helping Cadillac meet tightening federal efficiency and emission standards. Unfortunately, this move away from the tried-and-true big displacement iron blocks proved to be one of the most disastrous engineering gambles in the brand's history. The HT4100 produced a meager 125 horsepower, which was shockingly low for a brand that had once been synonymous with effortless power and smooth acceleration. In large, heavy Cadillacs, this meant lethargic performance and a driving experience that fell far short of luxury expectations. But underwhelming output was only the beginning of its problems. The aluminum block and cast iron head combination was a recipe for disaster due to differing rates of thermal expansion. This often led to head gasket failures, sometimes at extremely low mileage. When head gaskets failed, coolant could leak into the combustion chambers or oil system, leading to overheating, oil contamination, and ultimately catastrophic internal damage. The problem was compounded by Cadillac's use of fewer head bolts than ideal, which reduced clamping force and made gasket sealing even more unreliable. Another common failure point was the intake manifold gasket. The manifold, made from a composite material, would warp or crack under heat, allowing coolant to leak internally. This was a slow and silent killer of many HT4100s, as the coolant diluted the oil over time, destroying bearings and camshafts without the owner realizing until it was too late. Speaking of camshafts, premature cam lobe wear was a frequent complaint. This was partly due to the engine's lubrication system, which was not robust enough to keep all moving parts adequately oiled under certain conditions. Combined with the relatively weak bottom end, it meant the HT4100 often faced complete rebuilds or replacements far earlier than competing engines. To make matters worse, many Cadillac mechanics of the era hated working on the HT4100. Its unique design required special knowledge and tools, and because it failed so often, it became a frequent source of frustration for both technicians and customers. Some owners experienced multiple engine replacements under warranty, only for the replacement units to fail again within a few years. The damage to Cadillac's reputation in the 1980s was severe. Once known for building the most durable and refined luxury cars in America, the brand now found itself the butt of jokes about unreliability. Even decades later, the HT4100 remains a cautionary tale in the automotive world. The HT, a prime example of how rushing to meet government regulations without thoroughly testing long-term durability can destroy both an engine and a brand's image. While later Cadillac engines, like the 4.5 and 4.9-liter Evolutions, addressed many of these shortcomings, the HT4100's legacy was already cemented. For many, it is not just one of the most hated Cadillac engines, but one of the most hated American V8s of all time. Number 18. 2003 Ford 6-liter Power-Stroke Diesel V8. When Ford introduced the 6-liter Power-Stroke Diesel V8 in 2003 for its Super Duty trucks and Econoline vans, it was billed as a major leap forward from the outgoing 7.3-liter engine. Built by Navistar International, the new 6 promised cleaner emissions, more power, and modern features like advanced exhaust gas recirculation (EGR) and variable geometry turbocharging. On paper, it looked like Ford had a winner, a high-tech diesel ready to meet stricter environmental standards while delivering the torque heavy-duty truck buyers demanded. In practice, however, it became one of the most notorious diesel engines in modern truck history. The biggest problem was reliability, or rather, the lack of it. The 6 developed a laundry list of common, expensive failures that could happen at shockingly low mileage. One of the most infamous was head gasket failure, often caused by the engine's inadequate head bolts stretching under high boost pressure. When this happened, combustion gases would leak into the cooling system, leading to overheating and further engine damage. Repairing the issue typically required removing the cab from the truck just to access the engine, a labor-intensive job that could cost thousands. The EGR system, designed to reduce nitrogen oxide emissions, was another weak link. The EGR coolers were prone to clogging with soot and debris, which could cause them to rupture internally. When that happened, coolant would enter the intake system, potentially leading to catastrophic hydro-locking of the engine. Similarly, the engine's oil cooler was known to clog, which in turn starved the EGR cooler of coolant and triggered a chain reaction of failures. Fuel injectors were also a sore spot. The 6 used hydraulically actuated, electronically controlled unit injectors, HEUI, which were highly sensitive to oil quality and pressure. A slight drop in oil pressure, contaminated fuel, or internal wear could lead to injector misfires or complete failure. And when one injector went bad, it often wasn't long before others followed suit. The variable geometry turbocharger, while a technological step forward, added yet another layer of potential trouble. The vanes inside the turbo could seize due to soot buildup, leading to poor boost control and sluggish performance. Combined with the other known issues, it created a scenario where owners could be facing multiple, overlapping repairs within a short ownership window. The sheer volume of failures led to lawsuits between Ford and Navistar, with each side blaming the other for the engine's shortcomings. Meanwhile, owners, many of whom had bought these trucks for business use, were left footing enormous repair bills and dealing with costly downtime. Some resorted to bulletproofing their engines by replacing key components with aftermarket solutions, a process that could cost well over $10,000. Today, the 6-liter Power Stroke has something of a split legacy. In bulletproof form, it can be a solid, powerful engine. But in stock form, its record of frequent, expensive, and overlapping failures has cemented its place as one of the most hated V8 diesels ever built. For many owners, the 6 wasn't just an engine, it was a financial and mechanical nightmare. Number 17. 2004 Ford 5.4-liter Triton V8 3-valve. By the early 2000s, Ford's modular V8 family had established itself as a versatile workhorse, powering everything from F-Series pickups to Expeditions and even Mustangs. When the 5.4-liter Triton received its 3-valve per-cylinder upgrade in 2004, Ford promised more power, better efficiency, and smoother operation. On paper, it seemed like a major improvement over the older 2-valve version. But in reality, this engine became infamous for 2 major design flaws that turned routine maintenance and ownership into a nightmare. The first and most widely known issue was its spark plug design. Instead of a traditional 1-piece spark plug, Ford used an extended 2-piece plug that was prone to breaking during removal. Carbon buildup on the lower portion of the plug caused it to seize inside the cylinder head, and when technicians tried to remove it, the plug would often snap in half. Extracting the broken piece required special tools, extra labor, and often significant repair bills, sometimes running into the thousands, all for what should have been a simple tune-up. Making matters worse, earlier versions of the modular V8s had the opposite problem: spark plugs that could blow out of the heads entirely due to insufficient thread engagement. While the 3-valve Triton was less prone to blowouts than its 2-valve predecessor, the fact that both issues existed in the same engine family gave Ford a double black eye in the public's perception. The second major headache was cam phaser failure. The 3-valve Triton used variable camshaft timing (VCT) to improve performance and efficiency, but the phasers and their associated components were notoriously fragile. When they began to wear or fail, often well before 100,000 miles, they produced a loud metallic ticking or knocking noise from the top end. Beyond the irritating sound, failed cam phasers could cause rough idle, poor performance, and eventually lead to internal damage if left unaddressed. Repairs were expensive, as the process required significant disassembly, and many owners reported having to replace the phasers more than once over the life of the vehicle. These 2 problems alone were enough to tarnish the engine's reputation, but they were compounded by the fact that the 5.4 3-valve was used in some of Ford's most popular and profitable vehicles. F-150 owners in particular were vocal about their frustrations, as the truck's workhorse image clashed sharply with an engine that could fail them during basic maintenance or routine use. Fleet operators, contractors, and everyday drivers alike found themselves facing repair costs that often exceeded the residual value of the truck. Ford did make changes in later years to address some of these issues, but by then, the damage to the Triton's reputation was irreversible. Even today, used vehicle buyers often avoid mid-2000s Fords with the 5.4 3-valve unless they have proof of extensive engine work or modifications to eliminate the known weaknesses. In hindsight, the 2004 Ford 5.4-liter Triton V8 3-valve is a textbook example of how engineering missteps can destroy consumer trust. The combination of costly maintenance traps, premature component failure, and its presence in high-volume vehicles ensured that its problems were widely publicized. For many, it remains one of the most hated modern American V8s ever produced. Number 16. 1993 Cadillac 4.6-liter Northstar V8. When Cadillac introduced the 4.6-liter Northstar V8 in 1993, it was hailed as a technological triumph that would restore the brand's reputation for engineering excellence. This all-aluminum, dual-overhead camshaft, 32-valve engine was a radical departure from the pushrod V8s Cadillac had relied on for decades. Producing up to 300 horsepower in its most powerful form, the Northstar promised smoothness, high-revving performance, and modern refinement that could rival European luxury sedans. Initially, the Northstar delivered on much of that promise. It powered cars like the Cadillac Alante, Seville STS, and Eldorado Touring Coupe with strong acceleration and a distinctive, sophisticated engine note. It was paired with advanced features like a limp home mode, which allowed the engine to keep running for short distances without coolant by alternating firing between cylinder banks. On paper, it was the kind of forward-thinking engineering Cadillac needed to compete in the luxury market of the 1990s. However, as these engines aged, a fatal flaw emerged that would tarnish the Northstar name: chronic head gasket failure. The problem stemmed from the head bolts pulling out of the aluminum block, a result of inadequate thread engagement and the stresses of heat cycling over time. Once the bolts lost their grip, the head gasket would fail, allowing coolant and combustion gases to mix. This often led to overheating, misfires, and, if not caught early, severe engine damage. Repairing a Northstar with pulled head bolts was no small task. The fix required drilling out the block and installing specialized threaded inserts or studs, a labor-intensive process that could cost thousands of dollars. Because the engine was mounted transversely in most applications, simply accessing the heads often meant removing the entire drivetrain from the car. For many owners, the repair cost exceeded the value of the vehicle, leading to countless Cadillacs being scrapped long before their time. Beyond the head gasket issue, the Northstar also developed a reputation for oil leaks, particularly from its main seals and valve covers. While these leaks were less catastrophic than a blown head gasket, they contributed to the perception that the engine was high maintenance and finicky compared to the simpler V8s Cadillac had once built. The tragedy of the Northstar is that when it was running well, it truly was an impressive engine. It had the power, smoothness, and refinement to compete with the best luxury sedans of its era. But its long-term reliability woes, combined with the high cost of repairs, overshadowed its strengths. As a result, many mechanics came to dread working on Northstars, and used car buyers learned to approach them with caution. Today, the Northstar name still carries a stigma in enthusiast and consumer circles. For every owner who fondly remembers its performance, there's another with horror stories of head gasket failures and repair bills that rivaled the car's purchase price. The 1993 Cadillac 4.6-liter Northstar V8 will always be remembered as an ambitious engine that aimed high but fell victim to one crippling flaw enough to earn it a permanent place among the most hated American V8 engines of all time. Number 15. 1981 Cadillac 6-liter V864 L62. In 1981, Cadillac believed it was unveiling the future of automotive efficiency. The brand's new 6-liter L62 V864 engine was an ambitious leap forward, promising to combine the smooth power of a full-size luxury V8 with the fuel economy of a smaller engine. The key innovation was its cylinder deactivation system, which could shut down 2 or 4 cylinders during light-load driving, theoretically saving fuel without compromising performance when more power was needed. On paper, it was brilliant. Cylinder deactivation is common today, but in 1981, the technology was groundbreaking. Cadillac marketed it as a seamless transition between 8, 6, and 4-cylinder operation, controlled entirely by an onboard computer that monitored throttle position, speed, and load. Unfortunately, the computing power and sensor technology of the early 1980s simply weren't advanced enough to make such a system work reliably in real-world driving. The result was a car that often didn't know how many cylinders it wanted to use. Drivers complained of constant surging, hesitation, and abrupt changes in engine note as the system clumsily switched between modes. The transitions were anything but smooth. Sometimes the car would hunt between 8, 6, and 4 cylinders multiple times in a short drive, causing an irritating and unsettling driving experience. Worse yet, dealership mechanics were ill-equipped to diagnose or repair the system. Cadillac issued no fewer than 13 software updates in the engine's single model year of production in an attempt to make it work properly. But even after these updates, many owners remained frustrated. In some cases, dealers simply disabled the cylinder deactivation entirely, locking the engine into full 8-cylinder mode just to restore acceptable drivability. The underlying 6-liter V8 itself was not inherently unreliable. When run as a conventional engine, it could be a smooth and durable power plant. The problem was the overly complex and underdeveloped electronic control system that made the V8 6.4 unique. This complexity also drove up repair costs, as specialized components and control modules were far more expensive than traditional ignition or fuel system parts. Public perception turned sour quickly. Cadillac's reputation for refined engineering took a hit, and the V8 6.4 became shorthand for overpromised, underdelivered technology. While later systems from other manufacturers would eventually perfect cylinder deactivation, Cadillac's early attempt was a commercial failure that lasted only for the 1981 model year. Today, the L62 V8 6.4 is remembered as both ahead of its time and hopelessly out of its depth. It serves as a cautionary tale that being first to introduce a technology doesn't mean being the best at it, especially when the supporting electronics aren't ready for prime time. For many owners, the V8 6.4 wasn't a glimpse of the future. It was an expensive lesson in why some ideas are better left on the drawing board until the technology can catch up. That's why it has a secure place among the most hated American V8 engines of all time. Number 14. 2003 Dodge 5.7-liter Hemi Magnum V8. When Dodge resurrected the legendary Hemi name in 2003 with the 5.7-liter Magnum V8, it was a marketing dream come true. Chrysler's ads proudly touted the return of hemispherical combustion chambers, USS. Even if the modern design wasn't a true hemispherical layout, the USS, and promised truck and muscle car buyers a blend of power, torque, and modern efficiency. Initially, the 5.7 Hemi delivered on much of that promise, with horsepower ratings north of 300 and torque well suited for hauling, towing, and spirited driving. But lurking beneath the surface was a serious design flaw that would, over time, earn this engine a notorious reputation. The Achilles heel of the early 5.7 Hemi was its valve seats. The seats were press-fit into the aluminum cylinder heads, and under certain conditions, often related to overheating, they could drop out of place. When a valve seat drops, it can cause catastrophic engine damage almost instantly. Pistons collide with valves, combustion chambers are destroyed, and repair costs can skyrocket into the thousands. In many cases, the damage was so extensive that a complete engine replacement was the only viable option. What made the problem particularly infuriating for owners was its unpredictability. Some engines failed under heavy towing loads, while others dropped valve seats during normal commuting. There were even reports of failures in relatively low-mileage vehicles. Overheating could be the trigger, but it wasn't always present, meaning even well-maintained engines could suddenly and violently self-destruct. The issue wasn't just confined to trucks. Early Dodge Chargers, Magnums, and Chrysler 300C sedans equipped with the 5.7 Hemi also suffered from the same defect. And because the 5.7 was marketed as a modern interpretation of one of the most iconic American performance engines ever, the backlash from enthusiasts was especially harsh. Many felt betrayed. Here was an engine with the Hemi name, yet it carried a flaw so severe it could end its life without warning. Repairing a dropped valve seat wasn't cheap. Even in the best-case scenario, replacing the damaged cylinder head and associated components could run several $1,000s. In the worst cases, a full engine swap was required, and owners often faced the unpleasant reality that warranty coverage wouldn't always apply, especially on higher-mileage vehicles. Chrysler eventually addressed the issue in later years with design revisions, but by then the damage to the early 5.7 Hemi's reputation was done. On the used market, buyers became wary of 2003 to 2008 Hemis, often asking specifically whether the heads had been replaced or upgraded. Today, the early 5.7-liter Hemi Magnum stands as a classic case of a great idea undermined by a single, critical flaw. Its combination of strong performance and fatal weakness cements its place among the most hated American V8 engines of all time. For many owners, the sound of a ticking Hemi wasn't the music of muscle, it was the prelude to a very expensive repair bill. Number 13. 1981 Chrysler 5.2-liter V8 Imperial EFI. In the early 1980s, Chrysler was desperate to project an image of technological sophistication to compete with increasingly refined domestic rivals and the flood of well-engineered imports. When the company revived the Imperial nameplate for 1981 as its flagship luxury coupe, It promised buyers a car that combined American style with cutting-edge technology. At the heart of this promise was a 5.2-liter, 318 cubic inch V8, equipped with an advanced, at least for its time, electronic fuel injection system. Unfortunately, this bold step forward turned into one of the most embarrassing missteps in Chrysler's history. The engine itself, in carbureted form, was a tried-and-true workhorse. The Chrysler 318 small block had been in service for decades, known for its durability and decent low-end torque. But the Imperial's EFI system, designed and built in-house by Chrysler with help from Bendix, was an entirely different animal. The system used multiple sensors, an onboard control computer, and specialized fuel metering components intended to provide smoother operation, better fuel economy, and lower emissions. On paper, it sounded like a legitimate rival to the Bosch and Japanese EFI systems that were starting to appear in the marketplace. In reality, it was a disaster. The system proved to be extremely sensitive to temperature changes, wiring faults, and even slight deviations in fuel quality. Owners reported constant problems, hard starting, surging, stalling at stoplights, and unpredictable loss of power while driving. The control modules were prone to failure, and because the technology was new and poorly understood by most dealership technicians, repairs often consisted of trial and error part swapping, an expensive and frustrating process. The situation became so bad that Chrysler resorted to an extraordinary measure. The company initiated a program to recall many EFI-equipped Imperials and retrofit them with conventional carburetors at no cost to the owner. This move effectively admitted that the EFI system was beyond saving in the real world. For those who kept the original setup, drivability problems often persisted for the life of the car, and replacement parts became increasingly hard to find. The fallout was significant. The Imperial, meant to showcase Chrysler's engineering prowess, instead became a rolling symbol of its early 80s struggles. While the car's styling was distinctive and its interior was plush, the ownership experience was marred by constant visits to the service bay. The EFI fiasco also damaged consumer confidence in Chrysler's ability to deliver reliable, high-tech features, a blow the company could ill afford during its precarious financial state of the time. Today, the 1981 Imperial's EFI-equipped 5.2-liter V8 is remembered less for its innovation and more for its humiliation. It stands as a cautionary tale about rushing unproven technology to market without adequate testing or support infrastructure. While Chrysler would eventually master electronic fuel injection in later years, this early attempt remains infamous and firmly secures its place among the most hated American V8 engines of all time. Number 12. 1980 Pontiac 4.9-liter turbo V8 301 turbo. By 1980, Pontiac was facing the full weight of the malaise era. The glory days of the GTO, Firebird 400, and Trans Am SD 455 were long gone, and tightening federal emissions rules, fuel economy mandates, and corporate downsizing had left the division with only one V8 of its own design, the 301 cubic inch engine. On its own, the naturally aspirated 301 was an unremarkable power plant, prioritizing light, weight, and efficiency over performance. But in a last-ditch effort to inject excitement into the Trans Am lineup, Pontiac engineers decided to do something bold: bolt on a turbocharger. The 4.9-liter Turbo 301 debuted in the 1980 Turbo Trans Am as Pontiac's flagship performance engine. On paper, it sounded promising. A Garrett turbocharger, draw-through carburation, and a factory hood scoop with a Turbo 4.9 decal that screamed high performance. Rated at 210 horsepower, it was one of the more powerful American engines of the time, at least on paper. Unfortunately, reality was far less glamorous. The turbo setup suffered from significant turbo lag, the delay between hitting the throttle and feeling the boost kick in. Drivers would mash the pedal and wait a long, awkward moment before the power arrived, making the car feel inconsistent and unpredictable. When the boost finally did hit, it often came in a sudden rush that was difficult to modulate, especially with the crude carbureted fueling system. The engine was also prone to detonation, particularly when run on the low-octane unleaded gasoline that was standard by then. Adding to the headaches, the turbocharger was oil-cooled only, meaning that heat management was a constant issue. Drivers who didn't idle their engines before shutdown risked coking the oil inside the turbo bearings, leading to rapid failure. Replacing a turbo was an expensive proposition in 1980, and many owners simply gave up on repairs after one or two failures. Reliability issues, coupled with a lack of enthusiast aftermarket support, meant that the 301 Turbo never got the development time it needed to shine. Worse still, the Turbo Trans Am's actual performance numbers were underwhelming. Despite its advertised horsepower, the car's quarter-mile times were often slower than those of earlier, naturally aspirated big-block Trans Ams. Enthusiasts who bought the car expecting a modern muscle machine were left disappointed when it couldn't outrun many contemporary six-cylinder imports. The engine's short production run, only 2 years, from 1980 to 1981, Z, reflected Pontiac's own lack of faith in the project. By 1982, the 301 was gone entirely, marking the end of Pontiac's in-house V8 program. In hindsight, the Turbo 4.9 was a noble attempt to keep performance alive in a dark era, but it was hampered by inadequate technology, insufficient testing, and the compromises of the time. Today, the 1980 Pontiac Turbo 4.9-liter V8 is remembered less for its innovations and more for its frustrations. While it has a small cult following among die-hard Pontiac enthusiasts, for most people it stands as a textbook example of a great idea ruined by poor execution. And that is why it firmly belongs on the list of the most hated American V8 engines of all time. Number 11. 1982 Chevrolet Crossfire Injection V8. When Chevrolet unveiled the Crossfire injection system in 1982, it was marketed as a bold step into the future of fuel delivery. This early form of electronic fuel injection, fitted to the 5.7-liter V8 in the Corvette and the 5-liter V8 in the Camaro Z28 and Pontiac Trans Am, was supposed to deliver better throttle response, improved efficiency, and a taste of high-tech performance. Instead, it quickly became infamous under a much less flattering nickname, Ceasefire Injection. The Crossfire setup used 2 throttle body injection units, each feeding one bank of the V8, mounted diagonally on a unique intake manifold. In theory, this arrangement would allow for more precise fuel metering than a carburetor, bridging the gap between old-school mechanical setups and the multi-port injection systems that were just over the horizon. In practice, it suffered from poor airflow distribution, limited computing power, and primitive sensors that often delivered inconsistent performance. One of the biggest issues was drivability. Owners reported rough idles, flat spots in acceleration, and surging under light throttle. The system's early electronic control module was slow to adapt to changing conditions, meaning throttle response often lagged or felt erratic. Compounding the problem, the unique intake manifold design created uneven air-fuel mixtures between cylinders, hurting both performance and smoothness. For the Corvette, the Crossfire Injection 5.7-liter V8 was rated at 200 horsepower, the HE, which, while not terrible for the emission-strangled early 1980s, fell far short of the performance image Chevrolet wanted to project. In reality, real-world acceleration figures showed little to no improvement over the carbureted engines it replaced, and in some cases, performance was actually worse due to the system's quirks. Maintenance was another sore spot. The Crossfire system required precise synchronization between its twin throttle bodies, and any vacuum leaks, sensor malfunctions, or wiring issues could send the entire setup into chaos. Mechanics unfamiliar with the system often struggled to diagnose problems, and parts were costly compared to conventional carburetor components. Many frustrated owners simply ripped the Crossfire hardware out and replaced it with a standard carburetor, or later, with the far superior tuned port injection setup introduced in 1985. To make matters worse, the system was short-lived, lasting only from 1982 to 1984 before GM abandoned it altogether. Its brief production run and widespread owner dissatisfaction cemented its reputation as a failed experiment rather than a stepping stone to progress. Even today, mention of a Crossfire Corvette or Camaro will often draw groans from enthusiasts who remember the headaches it caused. In hindsight, the Crossfire Injection V8 wasn't so much a bad idea as it was a premature one. The technology simply wasn't mature enough in the early 1980s to deliver on the promises of smoothness, efficiency, and performance that GM marketed. Unfortunately, instead of being remembered as an innovative milestone, it became a cautionary tale in how not to introduce new technology. That's why the 1982 Chevrolet Crossfire Injection V8 still earns its place among the most hated American V8 engines of all time. Number 10. 1976 Chevrolet 305 V8. In the mid-1970s, Chevrolet was scrambling to keep its beloved small-block V8 lineup alive while meeting increasingly strict federal emission standards and fuel economy mandates. The result was the introduction of the 305 cubic inch V8 in 1976, a 5-liter variant intended to slot between the underpowered 267 and the more capable 350. On paper, it seemed like a sensible compromise. AT, smaller displacement for better efficiency, but still a V8 for those who wanted the image and torque. In reality, it became one of the most polarizing small blocks GM ever built. The early 305s were strangled by low compression ratios, tiny valves, restrictive intake manifolds, and two-barrel carburetors. Output in its debut year hovered around 140 to 165 horsepower, depending on application, which might have been acceptable for basic commuting, but left performance enthusiasts completely cold. The Malaise-era tuning meant that throttle response was lazy, acceleration was uninspiring, and top-end power was practically non-existent. Worse yet, the 305 often ended up in mid-size and even full-size cars that were simply too heavy for it to move with authority. In trucks, the situation could be even more frustrating. During the early 1980s, many Chevrolet and GMC half-ton pickups came equipped with the 305 as standard V8 power. When subjected to towing or heavy hauling, some of these engines developed a serious mechanical problem: pressed-in rocker arm studs that could pull out of the cylinder heads under load. This wasn't a catastrophic failure in the sense of blowing the engine apart, but it was enough to sideline a work truck and cause expensive repairs. Fleet managers and tradesmen quickly lost patience. The 305 also gained a reputation for being a dead end for hot rodding. While it shared the basic small block architecture, its smaller bore limited cylinder head and valve options. Many performance parts designed for the 350 didn't work as effectively on the 305, and the gains from upgrades were often minimal. As a result, enthusiasts usually swapped in a 350 or larger small block rather than spend money trying to wake up a 305. To be fair, the 305 wasn't inherently unreliable in stock form. If driven gently and maintained, it could deliver many years of dependable service. But in an era when buyers expected a Chevrolet V8 to have a bit of spark, the 305's dull personality and occasional mechanical shortcomings were enough to sour its reputation. It became the poster child for compromise: not strong enough to excite, not efficient enough to impress, and not robust enough in all applications to earn lasting loyalty. By the time GM phased the 305 out in the late 1990s, it had served in millions of cars and trucks, but it never shook its image problem. Today, the mere mention of a Malaise-era 305 brings eye rolls from gearheads who remember it as the engine you immediately pulled and replaced. That lingering disdain is why the 1976 Chevrolet 305 V8 earns its spot among the most hated American V8 engines of all time. Number 9. 1976 Chrysler lean-burn V8s. By the mid-1970s, Chrysler was under immense pressure to meet tightening federal emissions regulations and improve fuel economy without completely abandoning its large displacement V8 offerings. In 1976, the company unveiled what it claimed would be the future of cleaner, more efficient engines: the lean burn system. This was not a new engine in itself, but rather an early form of computer-controlled ignition bolted onto existing Chrysler V8s, like the 318, 360, 400, and 440 cubic inch mills. Unfortunately, it quickly became infamous as one of the most trouble-prone and hated innovations of the Malaise era. The idea behind lean burn was forward-thinking for its time. By precisely controlling ignition timing and running a leaner air-fuel mixture, Chrysler claimed it could reduce emissions, improve drivability, and boost gas mileage. To accomplish this, the system used an onboard computer housed in a metal box mounted directly on the air cleaner assembly to monitor sensors and adjust ignition accordingly. In theory, this could have been a game changer. In reality, the technology of the day simply wasn't ready for the harsh environment under the hood. The location of the lean burn computer proved to be one of its biggest flaws. Mounted above the hot engine, it was constantly exposed to extreme heat, vibration, and electrical interference. Over time, this led to unpredictable malfunctions, from sudden stalling to hard starting and severe hesitation under acceleration. Since the system controlled ignition timing electronically, any failure often rendered the car undrivable until repairs were made. Unfortunately, repairs were rarely straightforward. Lean burn systems were difficult to diagnose for mechanics accustomed to conventional distributors and carburetors. Replacement parts were expensive, and the system didn't lend itself to quick roadside fixes. For many owners, the most common repair was to rip out the lean burn hardware entirely and retrofit a traditional mechanical distributor and standard carburetor. Once this was done, many of the drivability problems vanished overnight, further proving that the core V8 engines themselves were not the issue. It was the lean burn control system choking them. Adding to the frustration, the promised gains in fuel economy were minimal at best. In many cases, mileage was no better than with conventional ignition, and sometimes worse due to the system's erratic behavior as it aged. The early electronic controls also struggled to cope with variations in climate and altitude, making them notoriously finicky in real-world driving conditions. By the early 1980s, Chrysler began quietly phasing out lean burn in favor of more reliable and advanced electronic engine management systems. But the damage to the brand's reputation had been done. For many drivers, lean burn became shorthand for unreliable, overcomplicated technology that solved few problems and created many more. Today, Chrysler's lean burn-equipped V8s are remembered as an ambitious but deeply flawed experiment. While it was an early attempt at the kind of computer-controlled efficiency we take for granted today, its poor execution earned it a permanent spot on the list of the most hated American V8 engines of all time. It's a reminder that being first to market with new technology means nothing if that technology doesn't work in the real world. Number 8. 1979 Ford 351M 400 V8 Variable Venturi Carburetor. By the late 1970s, Ford's 351M and 400 cubic-inch V8s were already suffering from the same malaise-era ailments plaguing nearly every American engine: lower compression, restrictive emissions hardware, and disappointing horsepower ratings. Once seen as solid, workhorse engines for trucks and full-size cars, their performance had been steadily declining in the face of tightening federal regulations. But in 1979, Ford managed to make matters even worse with the introduction of the Motorcraft Variable Venturi VV carburetor. On paper, the Variable Venturi carb sounded like a clever idea. It was designed to automatically adjust the Venturi size to match airflow demand, theoretically improving both throttle response and fuel economy. In reality, it was one of the most finicky, temperamental, and universally despised carburetors ever installed on a production vehicle. The system relied on a series of complex linkages, vacuum controls, and precisely machined parts that were extremely sensitive to wear, dirt, and even slight misadjustments. The result was an engine that often ran worse as it aged, sometimes dramatically so. Owners reported hard starts, rough idles, flat spots in acceleration, and unpredictable stalling. Mechanics, many of whom were accustomed to the simplicity of conventional 2- and 4-barrel carburetors, found the VV nearly impossible to tune correctly once it had even minor wear or vacuum leaks. In some cases, the carburetor's warp castings or internal vacuum diaphragm failures meant it was simply beyond repair, even when relatively new. The 351M and 400 V8s themselves weren't inherently terrible in terms of durability. They shared much of their bottom-end strength with Ford's well-known 335 series engines. But when paired with the VV carburetor, they became sluggish, unreliable, and frustrating to live with. The engine's already modest horsepower ratings, which often hovered around 150 to 165 horsepower in this era, felt even weaker thanks to poor throttle response. In real-world driving, that meant long, lumbering acceleration times and an engine that felt like it was fighting itself just to get up to speed. Many owners simply gave up on the VV carb entirely. A common fix was to replace it with a conventional Motorcraft or Holley carburetor, instantly improving drivability and reliability. Ford itself quietly abandoned the variable Venturi experiment within a few years, and the technology was never seriously revisited in the American market. By the mid-1980s, the VV was largely forgotten, living on only in the memories of those who had the misfortune of working on or owning one. In hindsight, the variable Venturi carburetor is a perfect example of how an otherwise decent engine can be ruined by a single poorly executed component. The 351M and 400 could have remained dependable, if uninspiring, torque producers for trucks and big sedans. Instead, the VV carb transformed them into some of the most frustrating engines of the era. For that reason, the 1979 Ford 351M 400 with variable venturi remains a cautionary tale that's shed and a worthy inclusion on the list of the most hated American V8 engines of all time. Number 7. 1977 Oldsmobile 403 V8. When Oldsmobile introduced the 403 cubic inch V8 in 1977, it might have sounded like a performance powerhouse on paper. After all, in an era when displacements were shrinking and horsepower was evaporating, here was an engine with a massive 6.6 liters of capacity. Enthusiasts hoped that maybe, just maybe, this big-inch small block would recapture some of the muscle car magic of the previous decade. But those hopes were quickly dashed. The Oldsmobile 403 was, in reality, a victim of its time. Emissions regulations and fuel economy mandates had forced automakers to rethink engine design, and by the late 1970s, raw horsepower was no longer the priority. Compliance was. The 403 ended up with a low-compression design, a restrictive carburetor setup, and timing curves engineered more for passing smog tests than for performance. Output hovered at a modest 185 horsepower, which was deeply underwhelming for such a large displacement engine. Worse still, the 403 had a significant durability flaw baked into its design. To save weight and improve cooling, Oldsmobile engineers created the block with windowed main bearing webs, essentially large cutouts between the main caps that reduce strength. This design was fine for normal, low-stress driving, but it made the engine notoriously weak under high performance or racing conditions. Any attempt to significantly increase horsepower risked catastrophic failure, as the block simply couldn't handle the extra stress. Despite these limitations, the 403 found its way into some high-profile cars, including the 1977 to 1979 Pontiac Trans Am and various full-size Oldsmobiles and Buicks. In the Trans Am, it replaced the larger Pontiac 455 in certain markets, largely due to emissions compliance. On the outside, the Trans Am still looked the part of a street bruiser, especially with its iconic Screaming Chicken hood decal. But under the hood, the 403's lack of real punch left many buyers feeling shortchanged. Mechanics and hot rodders quickly learned to avoid building performance projects around the 403. The block's structural weakness meant that serious horsepower builds were essentially impossible without risking engine failure. Even simple upgrades like high-lift camshafts or aggressive gearing could expose its limitations. As a result, many 403-powered cars eventually had their engines swapped for more robust Pontiac, Chevrolet, or Oldsmobile mills. In stock form, the 403 wasn't an unreliable daily driver. It could cruise comfortably for years if left unmodified. But its reputation suffered greatly because it was marketed in performance-oriented vehicles where buyers expected far more capability. This mismatch between image and reality cemented its status as a disappointment. By the early 1980s, the 403 was phased out, replaced by smaller displacement engines that were more adaptable to the new era of fuel economy and emissions technology. Today, it occupies a strange place in automotive history, a large V8 that failed to deliver the thrills its size promised. For enthusiasts, it stands as a reminder that displacement alone doesn't guarantee performance and that a weak foundation can ruin even the biggest of engines. That's why the Oldsmobile 403 has earned its place on the list of the most hated American V8 engines of all time. Number 6. 1980 Ford 4.2-liter V8 255 Windsor. By the dawn of the 1980s, Ford found itself in the same predicament as every other American automaker, NET, battling tightening fuel economy standards, choking emissions regulations, and a rapidly shifting marketplace. The Mustang, once the embodiment of affordable performance, had been through a difficult decade, and the second-generation Mustang II had already dulled the brand's performance image. When the third-generation Fox-body Mustang debuted in 1979, enthusiasts hoped for a return to form. Instead, for 1980, Ford introduced the smallest V8 it had built in decades, the 4.2-liter, or 255 cubic inch, Windsor. On paper, the 255 was a downsized version of Ford's venerable 302 Windsor V8, sharing the same stroke but sporting a dramatically reduced bore. The intent was to create a lighter, more fuel-efficient V8 that could still be marketed as an upgrade over a six-cylinder. In reality, it was anything but an upgrade. The engine produced a paltry 119 horsepower, the lowest output ever for a Mustang V8 at the time. With a restrictive two-barrel carburetor and emissions equipment that smothered what little potential it had, acceleration was lethargic and passing power was practically non-existent. If you were unlucky enough to drive a 1980 Mustang equipped with the 255, you'd find that it was slower than many four-cylinder competitors. 0 to 60 times hovered around the 14-second mark, a figure that would have been embarrassing even for an economy car, let alone something wearing the Mustang badge. To make matters worse for enthusiasts, the 255 was never offered with a manual transmission in the Mustang. It came only with an automatic, further killing any semblance of driver engagement. Beyond the lack of power, the 255 offered nothing compelling in terms of refinement or efficiency. Despite its reduced displacement, fuel economy gains were marginal compared to the 302, making the trade-off in performance all the more frustrating. And because it shared its basic block with the 302, it offered little in the way of weight savings. Its cylinder heads were unique to the 255 and severely limited airflow, meaning performance upgrades were impractical without major engine work or a complete swap to a 302. Unsurprisingly, public reception was poor. Enthusiasts saw the 255 as an insult to the Mustang's heritage, while the average buyer simply found it underwhelming and overpriced compared to more capable six-cylinder alternatives. Ford seemed to realize its mistake quickly, and by 1982, the 255 was dropped from the lineup in favor of the revived 5-liter V8, which brought some much-needed credibility back to the Mustang name. Today, the 4.2-liter Windsor exists mostly as a footnote in Ford history, a reminder of how misguided cost-cutting and regulatory pressure can combine to produce a product nobody wants. It's rare to see one still in service, not because they were mechanically fragile, but because most owners replaced them with anything, more powerful. For purists, the 1980 Mustang with a 255 under the hood is a symbol of just how far the pony car had fallen before the performance revival of the mid-80s. And for that reason, it firmly holds its place among the most hated American V8 engines ever built. Number 5. 2007 Chevrolet 5.3-liter V8 Gen 4 with active fuel management. By the mid-2000s, General Motors had refined its small-block V8 architecture to the point where it was both powerful and reliable across a wide range of applications. The fourth-generation 5.3-liter V8, used extensively in Chevrolet Silverados, Tahoes, Suburbans, and various GMC and Cadillac SUVs, seemed like the perfect evolution, efficient, torquey, and rooted in a proven design. But then came the feature that would haunt owners for years: active fuel management, or AFM. AFM was GM's take on cylinder deactivation technology, designed to shut down 4 cylinders under light load to improve fuel economy. In theory, it was a clever way to get V8 grunt when you wanted it and V6-like economy when you didn't. In practice, it became a nightmare for thousands of drivers. The system's design allowed excessive oil to be drawn into the deactivated cylinders, leading to oil consumption rates that were, in some cases, catastrophic. Owners reported adding a quarter more between oil changes, sometimes every 1,000 miles. The oil control issue had a domino effect. Excess oil fouled spark plugs, triggered misfire codes, and could cause premature catalytic converter failure. Worse still, AFM-related lifter failures became a common and expensive problem. When a lifter collapsed due to the AFM system's complex valve train controls, it often took the camshaft with it, leading to repair bills well into the thousands. For many owners, this meant either an engine rebuild or a complete replacement long before the odometer hit the mileage a small block Chevy should easily handle. The frustration was amplified by the fact that disabling AFM was not straightforward for the average driver. Aftermarket tuners and AFM delete kits eventually became popular solutions, but they required both technical knowledge and additional expense. For those who didn't take preventative measures, the damage often came without warning. One day the truck ran fine, the next it was ticking, misfiring, and down a cylinder. What made this situation particularly infuriating was that the underlying 5.3-liter architecture was otherwise solid. Without AFM, these engines could easily run hundreds of thousands of miles with routine maintenance. Instead, GM's gamble on early cylinder deactivation technology turned a dependable workhorse into one of the most complained about engines in the brand's modern history. The negative press and waves of owner complaints forced GM to make design revisions in later years. But for those who bought trucks and SUVs between 2007 and roughly 2013, the damage to the brand's reputation was already done. Today, the Gen 4 5.3 with AFM has become a cautionary tale in automotive circles. Even used truck buyers specifically ask whether AFM has been disabled before considering a purchase. It serves as an example of how a single innovative feature can sink the reliability of an otherwise excellent engine. In hindsight, GM's desire to chase fuel economy gains of just 1 or 2 miles per gallon came at an enormous long-term cost to owners. For many, that trade-off was unforgivable, cementing the 2007 Chevrolet 5.3-liter V8 with AFM as one of the most hated American V8 engines of all time. Number 4. 1968 Chevrolet 307 V8. When Chevrolet introduced the 307 cubic-inch small-block V8 in 1968, it seemed like a logical addition to the lineup. It was essentially a hybrid of proven components, done a 283's bore paired with a 327's crankshaft, done sec, designed to bridge the gap between the smaller displacement economy engines and the more powerful performance offerings. On paper, it should have been a versatile workhorse, but in practice, the 307 quickly developed a reputation as one of the most uninspiring V8s of the muscle car era. Rated at around 200 horsepower in its early years, the 307 was already underwhelming compared to Chevrolet's other small blocks. In passenger cars, it was often installed in mid-size and full-size sedans, where it was tasked with moving considerable weight. With low compression ratios and restrictive two-barrel carburetors on most variants, the 307 delivered lackluster acceleration that made even base-model 6-cylinder cars from competitors feel livelier. This was especially noticeable at a time when car buyers expected even a base V8 to provide confident passing power and a satisfying rumble. The problem was compounded by the fact that Chevrolet's lineup already had better options. The 327 and 350 small blocks were far superior in both performance and aftermarket support, while the venerable 283 NET, despite being older, was more rev-happy and enjoyed a stronger following among hot rodders. The 307, meanwhile, found itself in a strange middle ground where it was neither powerful enough for enthusiasts nor economical enough for the fuel-conscious buyer. In an era when image mattered, this lack of identity doomed it to mediocrity. Technically, the 307 wasn't a disaster in terms of reliability. In fact, it shared the inherent durability of other small-block Chevrolets, with long service life if maintained properly. But its small bore and cylinder head design severely limited airflow, making meaningful performance upgrades difficult without major internal work. For those looking to build a performance car, it made more sense to start with a 327 or 350 rather than trying to coax horsepower out of a 307. By the early 1970s, as emissions regulations began to strangle V8 output across the board, the 307 was hit even harder. Compression ratios dropped, camshaft profiles became milder, and power ratings sank into the sub-150 horsepower range in some applications. What was once just mediocre became outright sluggish, especially when coupled with the heavy, plush, full-size sedans of the era. Buyers noticed, and the 307's reputation sank further. Production of the 307 lasted until 1973 in passenger cars, with some truck and marine applications lingering slightly longer. But unlike other small blocks, the 307 never experienced a nostalgic resurgence. Collectors rarely seek it out, and engine builders often advise against spending money on one when more capable small blocks are so plentiful and affordable. For many enthusiasts, the 307 represents a missed opportunity, an engine that could have been a strong all-rounder but instead became a symbol of compromise. In hindsight, the Chevrolet 307's place in history is defined less by catastrophic failure and more by its sheer forgettability. It wasn't terrible, but it was never truly good. And in the high-stakes world of the late 1960s and early 70s, being forgettable was almost worse than being bad. That's why it earns its spot among the most hated American V8 engines of all time, not for blowing up, but for failing to inspire anyone to care. Number 3. 1979 Chevrolet 267 V8. The 1979 Chevrolet 267 V8 was supposed to be a solution, a leaner, more fuel-efficient version of the trusted small-block family, just in time for an era obsessed with emissions and mileage. But instead, it turned into one of the most forgettable and unloved engines GM ever built. With a displacement of just 4.4 liters and horsepower barely scraping past 120, the 267 was a case study in overpromising and under-delivering. Introduced as part of GM's strategy to adapt to tightening government regulations, the 267 cubic inch engine was created by reducing the bore of the 305 while retaining the same stroke. That alone wouldn't necessarily doom it, but GM didn't stop there. They saddled the engine with a restrictive 2-barrel carburetor and emissions controls that choked it even further. The result was an engine that made more noise and used more gas than many 6-cylinders of the same era, yet delivered less performance and excitement. In fact, it was so sluggish that even base-model sedans equipped with this motor had trouble keeping pace with traffic. Performance was, frankly, embarrassing. 0 to 60 times in the 16-second range were not uncommon, even when the 267 was installed in mid-size cars like the Malibu or Monte Carlo. With torque barely over 200 pound-feet, the engine struggled with any kind of load, making it an especially poor choice in station wagons, or when paired with air conditioning and automatic transmissions, AI, which was almost always. The fact that it was often paired with a highway-focused rear axle ratio only worsened the already lethargic drivability. Even loyal GM fans found little to love here. Unlike other small blocks in the Chevrolet family, the 267 didn't benefit from a wide range of aftermarket support. Hot rodders avoided it entirely because its small bore prevented the installation of high-performance cylinder heads or larger valves. Tuners quickly realized that they were better off swapping in a 305 or 350 than trying to squeeze any life out of the underachieving 267. Mechanically, the 267 wasn't a disaster in the sense that it didn't blow head gaskets or throw rods at alarming rates. Its sins were of a more frustrating kind: blandness, wasted potential, and failure to deliver on even the most modest of expectations. It was a product built entirely to satisfy federal regulations and corporate accountants, with no real regard for the customer experience. And when drivers inevitably got behind the wheel and felt the disappointing power delivery, sluggish throttle response, and underwhelming fuel economy, the resentment quickly followed. By 1982, the 267 was quietly removed from GM's engine lineup. Unlike more infamous power plants that inspired anger or ridicule, the 267 didn't even generate enough emotion to be hated properly. It just disappeared, a forgotten engine that left behind a legacy of mediocrity, a blemish on the otherwise proud history of the Chevrolet small block V8. In hindsight, it serves as a reminder of what happens when engineering takes a back seat to compliance. And that's precisely why it earns its place among the most hated American V8 engines of all time. Number 2. 1980 Pontiac 265 V8. When Pontiac introduced the 265 cubic inch V8 in 1980, it wasn't an act of innovation, it was an act of desperation. Strangled by newly imposed corporate average fuel economy, CAFE standards, and emissions mandates, GM's division scrambled to produce smaller, cleaner engines without the budget or time to develop something truly new. Pontiac's answer was to simply shrink its underwhelming 301 V8 even further, creating the 265, a 4.3-liter engine that offered all the disadvantages of a V8 with none of the benefits. Rated at a dismal 120 horsepower, the 265 was quickly recognized as one of the most pointless engines ever offered in a performance-branded car. Installed in the 1980 and 1981 Firebirds and Bonnevilles, it provided absolutely none of the torque or authority that customers expected from a V8. In fact, contemporary tests revealed that the 265 was outperformed by several inline-six engines of the era. Worse yet, the engine came mated exclusively with automatic transmissions, robbing any remaining driver engagement and further dulling acceleration. The 265 shared most of its architecture with the equally unloved Pontiac 301, but had an even smaller bore and lower compression. Its entire existence was predicated on the hope that a shrunken V8 would slip through federal regulations while still appealing to traditional buyers. But what Pontiac missed was the growing consumer shift toward more refined and efficient six-cylinder engines, VC, even from rival GM divisions like Chevrolet's 229 V6 and Buick's venerable 231. These alternatives were not only lighter and cheaper, but in some cases more powerful and economical than Pontiac's V8 deadweight. What really sealed the 265's fate, though, was its total lack of future. Unlike other GM engines that could be reworked or upgraded, the 265 was fundamentally a dead-end design. It had poor thermal efficiency, no tuning potential, and no appetite in the aftermarket. Pontiac itself would abandon the engine after just 2 model years, in 1981, replacing it with power plants sourced from other GM divisions, effectively ending Pontiac's V8 development. Critics at the time were merciless. Car and Driver described its performance as a shadow of what Pontiac used to be, and Road. Track labeled it one of the dullest V8s ever tested. To enthusiasts, it felt like betrayal. A company once associated with the rumble of the GTO and the raw power of Trans Am had now reduced its legacy to a wheezing underachiever. Even among emissions-era compromises, the 265 stood out as a particularly lazy engineering effort. Today, the Pontiac 265 is largely forgotten, and those who do remember it rarely have anything kind to say. It's a cautionary tale of what happens when a brand, forced into a corner, tries to preserve image with a half-hearted technical compromise. While other V8s of the era have gained retro charm or earned forgiveness, the 265 remains firmly planted in history's scrap heap. It was never fast, never efficient, never interesting, just a numbers game that failed to fool anyone. Number 1. 1975 Chevrolet 262 V8. At a glance, the Chevrolet 262 V8 seemed like it should have worked. After all, it was a genuine small-block V8, born from the same family that had given us legendary power plants like the 283, 327, and 350. But GM's move in 1975 to launch the 262 cubic inch variant marked a low point in the legacy of the small block series. Designed to help Chevrolet comply with increasingly strict fuel economy and emissions regulations, the 262 was an attempt to downsize the V8 formula while preserving traditional architecture. Unfortunately, it ended up doing neither well. With a minuscule bore and stroke and a displacement of just 4.3 liters, the engine mustered barely 110 horsepower at launch, an embarrassing figure for a V8 even in the smog-choked 70s. What made matters worse was that many six-cylinder engines of the time outperformed it in both real-world responsiveness and efficiency. The 262 was mostly installed in mid-size cars like the Chevrolet Monza and the Vega-derived models, where its low output was more a liability than an asset. Acceleration was lethargic, especially when paired with the standard 3-speed automatic transmissions and heavy emissions equipment that robbed even more power. The public's reaction was swift and merciless. Car magazines panned it for being slow, inefficient, and unworthy of the Chevrolet badge. Mechanics disliked the oddball part's compatibility, the REI-Z. While it was technically part of the small block family, many of its components did not interchange easily with other SBC engines, limiting its appeal among hot rodders and budget rebuilders. Even GM seemed to realize their misstep, as the 262 lasted only until 1977 before being quietly phased out in favor of better-performing small blocks like the 305 and 350. Part of the problem was that the 262 lacked the kind of refinement or engineering that would make its downsizing justifiable. Its horsepower per liter figure was abysmal, and its torque curve was uninspiring, especially compared to contemporaries like Ford's 302 or even Chrysler's tired but trusty 318. It didn't offer superior mileage, it didn't run particularly clean, and it certainly didn't excite anyone behind the wheel. The only real advantage the 262 offered was that it was cheaper to produce, but that came at the cost of consumer confidence and performance credibility. In retrospect, the 262 feels like the corporate embodiment of just good enough, But in the harsh landscape of late 70s American cars, just good enough meant painfully forgettable. Today, it remains one of the least loved Chevrolet V8s ever made, with virtually no collector interest, minimal aftermarket support, and a legacy built entirely on the disappointment it left behind. While other small blocks from the era have found redemption in nostalgia or performance upgrades, the 262 remains a punchline, a V8 in name, but not in spirit.